should one of us monitor Jabber in case? You'll do it?
I can just do it in the browser, right?
Yeah.
I don't have to install. Yeah, sure.
If you join the Meet Echo, you should be able to. All right. I'll start off and then I'll give it to you. Okay, good morning, folks. So welcome to Alto. And we're going to be here for 2.5 hours. For those of us that teach, you know we cannot sit for more than 50 minutes. So it's going to be fun. All right, so we have a full agenda, a packed agenda as usual. And please do take a note of the note well statement. As you're all aware, anything we say, write, in email lists, etc., is subject to IETF RFCs that you note there. That said, I will go ahead and turn it to Jan, and he'll walk us through the rest of the agenda.
All right. So as Vijay said, we have a full agenda. So here's what we're going to talk about. We're going to present in the chair slides what the status of the working group is, just to give an overview where we stand. We have a new milestone on CDNI footprint and capability interface objects. I sent an email on the mailing list, and actually we discussed it also last time. I will briefly update you about it, and later on actually I will present about it. Obviously agenda bash, and then we have one slide where we give a detailed overview on the milestones we have in the working group, just to remind everybody and where we stand. Yeah, I talk about later, maybe next slide. So yeah, so there was no physical meeting at the last IETF meeting. The last time the ALTO working group met was in Berlin. We asked actually on the mailing list for a virtual interim. There was very low interest, so we didn't go for it. We discussed it with our ed director, and she said, okay, then fine. We do think, however, that there is steady progress on all the milestones we are having. For all the milestones we have, and I have an overview slide later, we have actually very mature, pretty mature work. But we are a little bit behind schedule. So actually, Vijay and I took a look at the milestone deadlines, and we updated them. And they should be up on the website, I think. And Vijay and I really would like to finish the milestones. Is it? Are you just?
Yeah, no,
they're on the website, right? So we really would like to urge the working group to finish the milestones. Because we fear a bit that the energy will go away if we don't do it in the next couple of IETFs. So if you look at the new milestone deadlines, the last one is November 2017, and we actually think that's realistic. That's 2 IETFs from now. There is some new work use cases as always, and of course we gave agenda time, and that's fine, but we want to remind the working group that from a chair perspective, we really would like to focus on the charter items and get those done. But also at the next IETF meetings, if somebody has an interesting new use case, of course, if time allows, that's fine to present. But at this point in time, we don't think the charter will be updated as it is right now. Right. So here is just an overview on the new deadlines. Basically, there's just 3 deadlines. So the cost property, so the multi-cost draft just got submitted. So that's why March 17 is actually realistic. For all the other ones, we basically looked, is it quite mature? Then we gave November, or is it actually very mature and almost ready? Then we gave July. So yeah, that's basically how we did it. And then I just marked in red that there's a new milestone that Mirja, our area director, still has to approve, I think, but she told me she will. I'll talk about that later. That's the work we got from the CDNI working group. So as Vijay was saying before, in November, we really would like to take a look at the milestones, and we hope that we are done. And we can actually then, yeah, have the discussion on rechartering or dissolving the working group. Yeah. Yeah, so just briefly a reminder, I presented actually about this at the Berlin IETF. The CDNI working group has decided to use JSON objects for one of their interfaces. It's called the Footprint and Capabilities Interface. And actually, that working group produced an RFC 8008. I'll give you some examples later in the session when I present about it, how these JSON objects look. And the CDNI working group has decided that Alto should be the protocol to transport these JSON objects. So we need a new RFC. And we discussed it actually with the chairs of the CDNI working group, and so Vijay and I did, and our area director, and we all agreed that actually this is more appropriate work for the ALTO working group, because the document we needs to say, okay, how is error handling being done? How is it different than traditional ALTO? So basically, more the ALTO expertise is needed here. So I presented this last time. There were no objections. I raised it on the mailing list. So now we have a new milestone because there were no objections. So this work is basically now taking over by the ALTO working group. And yeah, it's actually something that must be done, because otherwise RFC 8008 is kind of useless. It specifies JSON objects, but there is no protocol to get them from A to B. So we must do it in a sense. Yeah, so here's the agenda. I don't want to go into details, but I would like to remind people that we have a packed agenda as always. And as always, I fear that some people will take longer than their allocated time. So we're going to watch it, especially as you see, I have a chair hat on right now, but I also have an individual presenter hat on, and my presentation is the last one. So I will pay particular attention that I will still have time. So I have a double interest here. So yeah, please keep it short. And here's basically an overview of it's a table that we produced to actually also for ourselves to see where we're at. The red drafts you see here are the ones where we have presentations today. So if you look on the left, all the milestones, the deployment considerations is done. The only milestone where we don't have a presentation today is the alternate server discovery. So we thought that was actually accepted as working group item at IETF Berlin, and we talked to Martin and Sebastian, and they actually submitted a 0.1 version. I don't know if you saw it, 0.0, sorry, version of a working group document. And so Vijay and I checked with them. They want to continue working on this and finish this. So they are confident that they can finish it within the milestone. For all other working group, for all other milestones, we have actually very mature documents. All of them will be presented. The statement you see here on the right on status, very mature, quite mature, is kind of rough, right? It's kind of, it's not very precise. For the ones that are not working group items yet, which are endpoint property extension document and network graph format document, we have some very mature individual contributions, and we would like to hum on them today to adopt them as working group item. At least that's what we as chairs think is appropriate at this time. Obviously, it's up to the working group to adopt or not. But we think if we want to be realistic with the milestones, which are 2 IETFs from now, we should at least hum for the most mature version. And for both of these documents, there has been a long process. Sometimes there have been merged drafts. So I think this is really, there are not many competitors out there. So it's really appropriate. So we kind of forgot the agenda, Bash. Are there any comments to the agenda? No? Okay, then I would say do you have anything else, Vijay?
No, I just want to thank Jensen, Gao, and Don for taking minutes. And Jan will be monitoring the Jabber chat room in case anybody wants to ask any question. So I think let's keep the focus on stuff we want to adopt today to see if we can get them to be working group items. And that said, we are ahead by 7 minutes. So let's start with the first presentation, which is cost metrics.
You can actually move the slides ahead with this.
So let me get your stuff on. No, this is mine. Yep. Did I miss your presentation? Cost metrics.
Yeah, this one. Okay. Good morning, everyone. My name is Qin Wu, and I want to give a quick update for this auto performance measurement cost metric draft. And this draft actually was adopted in the last IETF meeting together with Auto Canada draft, and to fulfill one milestone we list here. I think the time frame is wrong, need to correct. And so we changed the draft name because we want to performance measurement cost metric, not limit to the traffic engineer specific metric. So we changed the name to make it more generic. And this draft actually, the goal of this draft is to define several new cost metrics, because we think in auto-based protocol, they only define the routing cost and hop count are briefly described, but there's something, there's a lot of new cost measures related to the performance that hasn't been defined. That's why we propose this draft to cover this. And so in the last meeting, actually, main key issue is how to get in line with the RBPM performance measurement registry. So after the last IETF meeting, we actually we have some many discussion about this, and we actually one of change actually in this draft, actually we listed several performance measurement related metrics. So for each, we think most of the metric actually actually is existing performance metric doesn't need to be defined some new performance measurement methodology. So we try to reference some existing methodology defined in RBPM. Another issue actually is we in this draft we also have IANA registration. It called early we call this performance measurement metric registration. So it caused a lot of confusion. Actually, what we try to do is try to reuse the cost metric registration defined in the auto-based protocol. We just add additional entry. So we fixed this key issue, and also we made several other updates to try to improve this document, such as in the IANA section, we actually based on after 5226 bits, and we added the link to the registration, and we also update the section 2 based on the Sabian's comments, and we try to polish this section to make the whole document more concrete and in good shape. So in most work actually we try to get in line with auto Canada draft. We think these two draft actually has dependencies, so we really need to fix this so go to the key issue. As I mentioned earlier, actually for this draft doesn't actually want to define any new registration for performance measurement, performance metric. Actually, what we try to do is actually based on the auto-based protocol, we use this cost metric registration at additional entry. So so we think ANA section has some confusion, so we make several changes listed here. The first, actually, in the introduction section, we clarify the motivation for this draft. Goal of the draft is not actually define any new performance metric, and also we clean up the ANA section, and also we think for this cost metric we define in this draft also related to the performance measurement. So we add the reference to new cost metric defined in this document, but also we add a reference to the methodology defined in the RPPM draft and some other RFC related. So for this draft, I think we still need more review on this draft, because based on discussing with the author of this draft, we think maybe we need to consider other end-to-end metric, or consider how to do the aggregation for this kind of metric. These two actually related to each other. Actually, for example, in this draft, we propose some link-specific metric, but the more useful you focus on end-to-end and have end-to-end metric. For example, the bandwidth, available bandwidth. You really need to help all the client to select the endpoint to based on end-to-end metric. So it's very useful. So we think this is something we need to do more enhancement in the next update. And additional, actually, is we have another related draft is cost context cellular context draft from Sabine, and in this this will present in later. Actually, they may introduce some new metric, so we will consider whether we need to add some new metric into this draft. But for cellular network draft, actually, they require some new address space and related placeholder, but it's not scope in this draft. Just to make clear for this. Yeah, I'm done. Yeah. Any comments?
Richard, yeah. So one first quick question would be, for example, one protocol we're working on is the moment pass vector, so therefore we're going to add a new metric called abstract network element. Do you think that would be part of the metric defined here, or basically my high-level question would be, what's the mechanism to handle those kind of, for example, not really performance metric? They're more like, for example, a little bit more like BGP, AS hop count, AS. So would that be part of the effort in this document or not?
The metric you mentioned is hop count, right?
Metric name would be called abstract network element. Basically, then the result will be an array of network elements. They're abstract. They could be AS number. They could be something else. So
in that way, that means it is some kind of new metric. So we need to define some methodology how to measure this kind of metric, right? So
that right. I guess the interesting part here is that the metric will no longer will be measured. It somehow be computed by the server, of course. From the server would do the computation based on some internal other number, but it eventually calculate some kind. Let's imagine, for example, like BGP, and you collect all the AS number, and you say, hey, my proper metric is moment, but my BGP routing protocol is my pass vector. So therefore, now we have a metric we call pass mode. Cost mode is called pass vector, but metric is called abstract network element. Would that make sense in this framework, or I just want to see how you would react?
Yes, if we cover this, I think it requires more work, and I think I need to solicit input for this if we really want to cover this. Yeah.
So Sabine here. I would have an answer to your question, actually, Richard. So this draft, for the moment, the focus is to have network performance, so metrics reflecting network performance. And now we need to define whether the path vector, the metric abstracted network element, is a performance metric or is more of an informative metric that indicates, okay, this way you have such and such network elements and they have such and such properties. It's more about giving information rather than comparing two paths by looking at the ANE. So either we extend the scope of the draft and include performance and informative metrics, or or I would say not sure that ANA would fit in there.
Yeah, I agree with Sabine's opinion. Yeah.
I was actually going to suggest that maybe you take a look at the path vector draft and see if there's anything that you can pick up from there, from the viewpoint of incorporating in your draft. That's one thing. And the other thing is, if we are going to be introducing new address spaces in Alto, right now we have IPv4 and IPv6. If we foresee including new address spaces like MCs or MAC addresses or something, then I do not believe offhand we have to modify the charter. I believe we can do it within our current charter, but then the work has to start soon. So if
what do you suggest for this job? You think we should cover MAC addressing?
I think that's up to you to drive the work so that the working group can agree that, yes, we need new metrics for cellular networks. And if those new metrics include a new address space, then this is what it should be, and try to, at least get the work started as soon as possible and see if we can finish by July or November.
Okay. Yeah.
Okay, thank you. Next up is Sabine, contextual cost, right? All right. This is it, right?
Yes.
Please.
So I might take more than 10 minutes, but I think I can squeeze the 2 hours.
For now, we are good
No,
with
not
time.
squeeze.
I think,
but I
yeah,
can say them.
we are,
Okay.
for right now, we're okay.
So this is a new protocol extension proposal. So next slide, please.
You have the clicker.
Oh, sorry, I thought I did.
Okay.
The right arrow takes it forward.
Okay. Oh, great. Okay, so we start with a use case. So we have user equipment here.
You can,
That is-
there's also a laser pointer
Oh,
on top.
that's just. Oh, this
Yeah.
one. Okay. Oh, okay. So we have a user equipment.
We use the
sits-
best technology in IETF.
that sits in a cellular network, and this cellular network is covered by a local auto server that provides calendars for quality indicators on the connection quality. So this, okay, the next slide, sorry. Okay, so the user equipment is running an application, and this application involves a transmission of unattended data, where unattended data is defined in 3GPP as data that is conveyed within an application and that can tolerate some delay in its transmission. Typically, it's an attachment in an email, it's a video in a social network application. So the application wants to know when it is best to connect and to transmit those data. On the other hand, the UE can receive from the network information defined in 3GPP as well that tells instantly whether or not it is allowed to transmit such data. So this information is called UDI, so unattended data indicator. I will say UD now for unattended data. And so it takes value either allowed, which indicates that the connection is of good quality, or it can take value not allowed, which indicates that the quality is not so good. So you have here auto calendar values in time slots that are like 1 to 5 minutes, for example, and within those slots you have like every 1 millisecond a UDI that arrives and that tells you whether it's UDA or UDNA. Okay, so now suppose the application takes a simple auto calendar, and we have the rule that I can transmit UD when the quality is equal or greater than 3. So let's say I pick that slot, sorry. So, okay, so I pick that slot and I decide I will transmit during that slot because I have time, but not so much. So if I have a better insight with respect to UDNA and UDA, well, I can figure out that when I have UDNA, actually the quality is rather 2 than 3, which means that there is a high probability that the value of UDI is not allowed, which means that I have a high risk of wanting to transmit those unattended data and not being able to. And well, if it is the case, I waste battery, I waste processing resources, and as these kind of data have to be ultimately transmitted, I run into problems. So now the problem is that I don't really want to define a separate metric for each value or each type of context and register, and I don't want either to have a request input that is too complicated with tons of metrics. And of course, I cannot afford getting hundreds of cost maps depending on the such a parameter value, because I have There is also another thing with the UDI defined in LTE. It does not specify, for example, whether it is in the uplink or the downlink direction. So another use case, much simpler or shorter to explain. So back in the IP world, for example, a UE may want to know via which access path to connect to an application endpoint here. And this decision, the decision may depend on access type and SLA. And this is interesting because very often now we may want to consider both routing cost and bandwidth, for example. So myself, I pretty often switch off the Wi-Fi because it's so poor, and my LTE offers me a nice rate, and I can afford sometimes during weekends to connect via LTE. And sometimes I have no choice, I have to. So third use case is when an Alto client wants cost maps with values depending on different policy. And this discussion was launched back in 2012 for CDN application. I believe it was Ben, and so the need was also already existing, given that cost map for CDN may be really heavy. So again, for these two use cases, we have the same problem as for the use case number one. So the proposal here to address this in a light way is to extend the cost information conveyed by the base Alto protocol by providing for a same cost metric several values where each value is depending on a qualitative criteria as opposed to quantitative or time-based. So the approach here is very simple. It just consists into introducing a member called cost context in the IRD resources capability. And this cost context is an object that has, well, one or two members. In the IRD, it has the cost type name to which these cost context parameters apply. And then you have a combination of parameters that you can arrange logically so as to make richer choices and requests. For example, with this design, you can get an Alto calendar of cellular connection cost in the uplink and downlink direction, and depending on whether you have unattended data load or not. You can get routing cost values in the case of cellular and Wi-Fi access, and in case of you have SLA number 3, for example, and you can get those cost map with values for policy, PI, PH, PW. So on the applicable Alto services are the filtered cost map and the endpoint cost service. So here quickly an example IRD. So, okay, so if I take that use case 1, you have a information resource that offers calendars for 2 metrics here. And it says that for one, it has a cost context parameters that is only recognized by the Alto client that are aware of this extension. So, and this client understands that for metric num RF cost, for example, it can use context parameters that are arranged this way. Implicitly, this is an OR combination and this is an AND combination, which means that you can pick UDNA or UDA or UDNA with and uplink, and or UDA and uplink or downlink. Okay, so with in this use case, so for example here, this is the example request. So you add those parameters. In this example, the client has selected all the possible combination, and in return, you get your metadata. In your meta, you get again what you chose, okay, and you get for each. So, for example, you ask cost from cell 1 to cell 1, and cell 2 from cell 2 to cell 1 and cell 2. This is another extension. I will go briefly over it if I have time, but it's not the focus. here. And so here from cell 1 to cell 1, which means within a cell. So you have a calendar of 12 values, I guess. And for each value, you have for each slot, you have 4 values, depending UDA and uplink, UDA and downlink, UDNA and uplink. Of course, you do not have to choose all the combinations. Second example, so the use, we have an IRD, for example, where for that multi-access decision making. So here I can pick cell or Wi-Fi or LAN and SLA or SL2 or SLA3. And in that example, we suppose the client requests 2 combinations, cell and SLA3 and Wi-Fi and SLA3. We make and the response is as follows. So for each metric, we get 2 values. So one for cell and SLA3, and the other one for Wi-Fi and SLA3.
So in 10 minutes are up.
Sorry?
Just letting you know, 10 minutes. Are up.
Okay. Okay, so the required auto extension for the use case in this draft are, okay, well, as follows. So we first have to specify that those cost context objects. And also you may have noticed other implicit extensions. We used, for example, extended inputs in the request where you have several source and destination pairs, and this is also suggested in the AutoPath vector graph, the graph mod, the draft about the path vector. And another extension, we need to define cost metrics for cellular and wireless networks, and this is being discussed. This can be done in the auto performance metric. And third extension, we need to have for cellular and wireless network entities, we need to define new address spaces and properties, and the placeholder would be the draft on unified properties. So the design principles are the following. So we want to keep backwards compatibility with the base protocol. We do not want to introduce new media types. We can logically combine the context parameters. And the design option for cellular network is to map a cell into a PID with connection cost within a cell, called PID1 as conveyed as a PID1 to PID1 cost, and possibly in the uplink and downlink directions. And the next step, I intend to correct the IRD examples. We need to specify the rules to arrange the logical combinations of the parameters. We need to add example for the property service, because this can be used in the property service as well. And last, I would like to collect the working group feedback on this proposal, whether it is a good idea to adopt this extension, whether you like the opinion, whether you like the design, and whether there would be other suggestions. Okay, thank you.
I think this is very cool. And so basically, so conceptual principle, all the costs, you always have point A, point B, and you ask for a single number, because right now calendar would give you a little bit more numbers. And so now you are really seeing is not only, for example, you look at point A, point B, you also actually would have all kind of attributes associated. For attribute 1, I think you call context 1, for example, uplink, downlink, and SLA 1, 2, 3, they give you all kind of different numbers. So I think that's very cool. One first question would be, for example, would that context value widely be announced in IRD? Can they also become some kind of, if they come from IRD, that means they're hard-coded. Uplink, downlink, and so on. It's possible even, for example, to query those contexts. Essentially means, for example, there's some level of meta service. Because, oh, okay, it's not limited to SLA 1, 2, 3. Actually, there's a context category called SLAs, and therefore you query SLA, they'll tell you now for my network I have 3, and another network may say I have 5. So therefore, then you use that context, then the query so therefore becomes essentially make it slightly more extensible. I don't know if that makes sense or not. So that's my question number one. Oh, wait.
Yeah, that your question makes sense, actually.
So you can chat and monitor it.
My first guess would be if you use context parameters, it should not be properties that takes too many values, because then it's context parameters. I rather see it for parameters that have a limited set of possible value. Otherwise, you should use it as a property or as a metric and put it in a constraint.
Yeah, sure. I'm not, yeah, even though very small number, but still, for example, SLA1, SL3, and maybe some other metrics. So therefore, still a very small number. Basically means hard code seems to be, well, of course, you can see it's not hard code because you're still announcing using IRD. Essentially, there's some kind of get service to announce it. But still, what if I want to change? What if dynamic? What if, for example, IRD supposed to be cached forever, quote unquote. But the result, for example, you can, for example, right now my network offers SLA 1 and 3, and later it might become, and for example, 2 and 3, and so on. So therefore, if you do the query, then would allow you to get the result in a more adaptive way.
Yeah. So I started looking at it. But it's not that easy to decide, because after some point, it just moves from parameters to a variable, or it should not, again, but we can discuss this. But I tend to, because otherwise, if you have a calendar with a context parameters that can take like, well, maybe not many, but if it takes too many possible values, then it becomes kind of a variable. So, but yes, we definitely want to look at it and discuss it.
Hi, Lyle Burt, Sprint. I'll just make them as observations rather than questions so we can keep to time. But basically, 3 points. One, with Next Radio and 5G, right, we have the CU-DU splits. So I still think, given the way we're representing cells as PIDs is correct, but I'd like to work with you more maybe on getting back to our respective 5G counterparts to see if that's still the proper representation going forward for that particular split, especially if we're looking at kind of VBUs split in that model between C1 and C3 reference points in that design. Two, the other thing I was thinking when you were bringing up the use case in unattended data is whether or not this particular Alto application itself would be unattended data and itself be access barred under the AC/DC feature, which is really right. The whole point of this use case is so that I can understand that my unattended data, right, in terms of restrictions as well as you know, where we're at in terms of congestion. So the irony would be if an application which is unattended data comes up and isn't actually identified as an Alto application and then flagged by a carrier as not being barred, then the actual UE would never get the data to realize that the unattended data metrics are in effect. So it's kind of this weird situation. So there would have to be some work with operators and maybe even an LS going across to let them know so that we don't accidentally bar Alto as an unattended data app and then don't give anyone congestion metrics. So the irony there is pretty thick. And then the last thing, we are talking about UEs with NApps. So it's probably important to describe, especially for operators, you know, the types of metrics are being exposed and whether or not access restrictions are in place. We don't talk a lot about any sort of restrictions or access across operators for Alto data, and we don't talk about what we expose within the UE or within the applications themselves in this group. Now that's fine, but when you talk about practice and successful implementation in an operator, we are worried about the types of information exposed and to whom. Because especially if it's a cell serving a small amount of people, then it becomes more of a privacy implication than anything else. So those are three things that I'll take them offline, but I just want to bring them up as observations that I'd like to work with you on offline and maybe hopefully get a little further progress. Thanks.
Yeah, thanks a lot. I will think about
Now, can you even post to the mailing list or make more people to be known?
But I think one other takeaway is from the comments is we need to make sure that we don't have contextual things that change too rapidly, right? That's one of the main issues. Because from the beginning, the ALTO working group was chartered to, convey things that don't change too often. So I understand this is, as far as I understand it is, you want to have an ALTO extension where you say, okay, I give you 3 different answers to your question, and I tell you, depending on this is your metric, right?
Yes.
But you need to make sure, and I think this from a or charter perspective, so I kind of have my chair hat on right now. Need to make sure that these values are something that don't change too often. Otherwise, you're going to have feedback loops or right?
the one thing I'd say is you have to remember from a wireless operator's perspective, 200 milliseconds is a really long time. So we do have to keep reminding people that we're not talking seconds or hours and stuff too as well. So.
Yeah, but would you suggest to have ALTO information every 200 milliseconds?
No, I'm just saying from my perspective, 200 milliseconds is a really long time. I've made 20 to 40 decisions, scheduling decisions, over 200,000 cells across the US.
Right.
No big deal, right?
But if I may say, so this is exactly how we separate the things. We really stick to the point that ALTO is non-real-time information. It's more there to stabilize the traffic and avoid.
I guess all I'm saying is the
And-
document should have some text warning implementers or actually ISPs of this, danger. So right, because this kind of encourages people maybe to think more of real-time changes.
Yeah. Okay.
You get
So
my point. I'm just saying.
I got
I
it.
think when we were doing the charter for the initial ALTO, we were more worried about the wired network cases where we do not want BGP information that changes very fast or other information to be impacted. Now, a case could be made that, the wireless or radio access information is, not intrinsic to IP routing, for instance, because that's all it's doing is injecting packets into the IP network. So if that changes in 200 milliseconds, is that okay? I don't know. We need to have a larger discussion about that. But I think we need to move on. So
Yeah, we really need to.
So one last comment is this is one of the motivation of this proposal. You have that UDI that falls every 1 millisecond. By no means do we want ALTO to convey it. So ALTO anticipates and say, okay, for the next 5 minutes, if you have that indicator, then take this decision.
So you bet, yeah.
Brief
Hi,
comment, please.
Sabine. I'm Dawn, and I have one problem about the cost context. So shall we move the slides back to page 8? No, not this one.
sorry.
Page 8.
So it's
I'm
too
moving ahead of
late.
myself. Can we cost context?
Yes.
Page 8.
So I think the current cost context is based on the base protocol, right?
The current, well, there is no such thing in the base protocol.
No, I mean that does the cost context support the multi-cost? Does it work in the multi-cost?
Well, it has to. When I talked about the design principles, it's like for the calendar as well. We want to have backwards compatibility with the base protocol, and we want to be compatible with multi-cost, with the other existing extensions. Like calendar has been made compatible with multi-cost. So I did not finish the design because I first wanted your feedback, but definitely it has to be compatible with multi-cost. But I did not give any examples right now because the focus was about the extension.
Yeah, so my suggestion is that since each cost type might have a corresponding cost context parameters, right? So when you list a list of context parameters in the field context parameters, how can we distinguish which context parameter is for which cost type.
Yeah.
In the multi-cost.
Okay. So, first of all, this is something we can take offline, but definitely you just follow the design of calendar of multi-cost. In your meta, you embed everything. So, for example, you asked for like 3 metrics, and for one of them, you arrange the array so as to the metadata so as that the auto server understands. But it's a very good question, but I'm not there yet. So we really need to specify it very precisely in the design how we arrange the input, the request input, and the responses so that the client and the server understand each other.
Sabine, we have to move on.
Yeah.
We have less than 10 minutes, and we have
Technically,
to
one very quick comment. And because I do see, for example, one thing now is we're making a lot of extension, and seems to be the case so far that we're utilizing mostly the default behavior that if you have a message which you introduce more attributes which you don't understand, the client or server will just ignore it. And then therefore we're trying to use backward compatibility using this approach so far. It seems to be common. It looks like that's what you are the path you are going to. But I do want to point out, at least in a very early part, one key thing we struggled so much for the base protocol design was we introduced so many media types. Therefore, I think the motivation was we have a lot of media types. People say, why don't you just have a JSON application JSON? Therefore, you have single type like all these people doing. And we have multiple is because then we allow piecewise upgrade and extension. So therefore, I really think that's probably a very bigger picture design philosophy that we probably should discuss, for example, on the meetings or by the working group. But so far, it seems like we're not using that mechanism at all. And that seems to be a very interesting thing.
Okay, so I will stop you at 9:55 because we are now.
Okay. Which means I have 5 minutes.
You have basically
8 minutes for the next 2 presentations.
Okay.
Right.
Okay, so let's go for the first one. So this is an update on multi-cost. So previously, it's auto calendar. So previously it was a personal draft that was moved to a working group document in Berlin. So, this is the first update since Berlin. So basically the diffs are on rewarding, cleanup, and updates for backwards compatibility with the base protocol and draft organization. So nothing really big happened on I didn't really touch the design of the product of the extension. So the design updates are for example, if an auto client and server support multi-cost, so the responses for filtered cost map and endpoint cost service are updated, just similarly to the multi-cost as discussed in Berlin. So we add a value, a cost type field set to this brace brackets empty. So, and this has been done, this update has been done in section 4.1.2 and 4.2.2. Then there are updates on the draft organization in order to drop section 5. So section 5 on the use cases for auto cost schedule. So we basically these 3 sections, the title has been renamed. So the content is the same, but the title has been renamed to use case and example instead of example transaction, because each of these sections contains the scenario and the example transaction. So then there is section 4.3, recap of rules related to auto cost. So the text is being progressively moved to other section, and the goal is as well to remove this section. So the next proposed updates are on example cost metrics that need to be aligned with a performance metric draft. So typically names such available bandwidth and latency need to be replaced by names for end-to-end path, because these ones are being used right now for link-based metric. Also, calendar needs to be considered for link metrics as well. Another update would be that in section 3.1, the calendar attributes specification needs some cleanup and also updates where this member actually must be mandatory or must not be mandatory, sorry. And in section 5, the use cases for the ALTO cost schedule will be dropped. So the next step is to collect the working group feedback on this version and this work. We would like to progress towards working group last call as fast as possible. And in the next version, we will integrate the proposed next updates and working group feedback. And also please note that there are calendar use cases in 2 drafts, the performance metrics and the ALTO cost context.
Okay, good. I think for working group last call, we'll do it on the email instead of. If there's any brief comments, please go ahead while I put up the next one.
I was just going to say the next one is multi-cost, and I don't think there's much to present there, right?
No.
Right. Okay, go ahead, but still, go ahead.
So, yeah, this is so the progress on multi-cost. So since Berlin, there has been a pretty a good amount of updates upon working group last call, feedback, I'm sorry. So there was a version 3 posted in August that addressed the working group review. And so we worked on the terminology, clarified the constraints and all constraints in the specification, did some spelling check, performed some design update in multicast server responses, where we added that member here as discussed in Berlin. We posted a version 4 in September where we did last spelling consistency check and further clarified the OR constraint. This is the new item that was pretty tricky to clearly explain, to make it really clear to the reader. And the version 5 was posted in February and for the Shepherd write-up. So again, thank you to Kai, Hans, Richard, Chang, and Chin. I hope I pronounced it correctly. So then we had the updates upon area director feedback. So the version 6 was posted in March of this year. So again, we further clarified the overview with a definition on filtered cost map and endpoint cost services. We explained the design choice of using an index to refer to cost types rather than their names. We clarified the multi-cost server response specification, why, especially the wording actually. So on this point, I would like to say thank you to Mirja. And then we had the IANA and IETF last call review. So the IANA review was okay. There was a SecD review by Magnus. And so he had one question on additional DDoS risk due to complex multi-cost requests. So my answer was the following by email. So the answer is that we believe that this proposal does not cause any additional security issues compared to the base protocol. The multi-cost optimization even tends to reduce the on-the-wire data exchange volume compared to multiple single-cost auto transaction. Likewise, the risk related to massive multi-cost requests is moderated by the fact that multi-cost constraints further filters auto responses. So the more constraints you put, the smaller your map in the response will be, because you filter even more. And the first part of the response reflects that that was one of the main goals of multi-cost, is to just get, squeeze 3 requests and responses in one transaction. So there is the risks are inferior or equal to the risk related to the base protocol. So I think,
Yep.
yeah. Okay.
All right.
All right. For those of you that walked in late, could you please make sure that you sign the blue sheets? There should be blue sheets on either side of the aisle. I think, Richard, you're up next. Thanks, Sabine. Perfect. Don, there's a clicker.
You can go to the next slide, please. Okay. That's next slide. At the point, I don't know this one. No, where's the pointer?
Pointer is at the top.
The top. Okay.
So, good morning, everybody. I believe that in the last IETF meeting that we presented the path vector version 3. And during all these days, we have come up with some new ideas and made some progress. So I'm going to present the ideas that we mentioned in path vector version 4. And so the draft goal of the path vector is to address the network graph representation milestones. And at the last IETF 96 meeting, we have proposed 3 key remaining issues and have proposed the potential design choices for each. But actually, we hadn't made any decision choices. So during all these days, we have investigated all the possible design choices and finally go through all these ideas and made the final decision and the design ideas. Of course, this topic will include something that we mentioned in the draft path vector version 4. But since we have come up with the new ideas during these 2 last weeks, so I will also mention the latest idea that we have, and I wanted to share with you that. So let's have a recall of the remaining issues. We have 3 key remaining issues at IETF 96. The first issue is that how to encode path vector in cost maps. Shall we define a specific cost type for path vector, or we are going to use a unifying scheme which can also handle the multi-cost and cost calendar problem? For issue 2, what is the proper query format? Now we have 2 choices: to use the path vector in a native filtered cost map or endpoint cost map query. Another choice is that we design a new flow-based query format. The last issue is that how to provide path vector network element properties. Also, we have the inline mode and the reference mode. So in the next slide, we have made some decisions about these 3 issues, and I will go through these solutions in red color in detail in the next slides. For the first issue, how to encode path vector in cost maps, we chose the specific cost type. So now we introduce a new cost type with the cost mode being path vector and cost metric being ANE. Here, the cost mode path vector and the cost metric ANE has to be used together. That is to say, you cannot use the cost mode being path vector and the cost metric being routing cost, or the cost mode being numerical and the cost metric being ANE. It's not acceptable. So what does the cost metric ANE stand for? Actually, ANE is short for Abstract Network Element. It can be a device, an endpoint, link, or an aggregation of network links. And to encode the cost value for path vector, we make the cost value into an array. Each cost value, either in the cost maps or endpoint cost maps, is a JSON array of abstract network element names. As you can see here, it is an example of the cost value in legacy cost maps. In the base protocol, it specifies that the cost value is of type JSON value. It is a generic idea. That is to say, for example, for cost mode numerical or ordinal, it is specified to be the JSON number. So here, we extend this idea to allow the cost value for path vector to be an array of network element names. Below is an example of what a path vector cost value looks like. So it can be an array of network element L001, L002, L003. This sequence form a single cost. The second issue is that what is the proper query format? Actually, we still support the legacy FCM or ECS query format. However, there are some limitations because the request format of such query is a cross-product query. It doesn't allow flow query. That means if there are 4 end hosts, source 1, source 2, and destination 1, destination 2. If the clients just want the cost value for source 1 to destination 1 and source 2 to destination 2, it cannot be achieved through this method. So we extend the request format to be like this. We introduce a new JSON object named PID flow filter. It is a single source to destination flow. And the PIDs and PID flows are not able to appear at the same time in the request. That means either the PID appears or the PID flows appears. This design idea is backward compatible for clients who is aware of the PID flows, but server who is not aware of such new things, then the client might send a request with the field PID flows. But the server will ignore this field, and the server found no PIDs included in the request. So the server might return an error named missing valued to the client. For the last issue, it is about how to provide the path vector element properties. We have the inline mode and the reference mode, but we decide not to use the inline mode for the following reasons. Here are 2 examples. The first example is the resource entry of the filter cost map, and the next example is the response of the corresponding filter cost map. To support inline mode, the resource entry have to publish what prototypes that this resource support in its capability. So here we choose the design to add a new field prototypes in capabilities. It is acceptable, but it is not a good design idea because the capabilities field actually depends on the value of the cost type names. So we don't want this idea. Also, to allow the inline mode, the response format of the filtered cost map has to be extended. We need besides the cost map to be included in the response, we need another resource named NAP map. So the response format has to be changed largely. So here we prefer the reference mode. Here is the example of the information resource entries. The first one is the cost map named PV map 1. Second one and the third one are prop maps. And the NAP map 1 provide prop types named delay. The NAP map 2 provide prop types named bandwidth. So the question here is, how could the client of the cost map know what are the prop types that this cost map can provide? So here we have come up with two requirements. The first one is the client has to know which NAP map to get the corresponding ANE properties. The second, since the response can depend on the query, the set of ANEs is dynamically generated. Let's have an example. Yeah. The response of the cost map and the response of the NAP map are correlated because of one query. So the design idea is that how could we provide such query-specific information? To satisfy the requirement 1, we actually add a new field in the resource entry. It is named property map at the moment. So the cost map has to publish what NAP map it has to refer to in this capability. So, for example, the cost map refers to the NAP map 1. So the client can retrieve that NAP map 1 supports delay property through this property map attribute. To satisfy the requirement 2, we introduce a new idea named the query ID. Here is the example of the cost map query and response, NAP map query and response. The query of the cost map remains the same. However, the response of the cost map is extended. The VTag field has to be returned. And we extend the VTag object to include a new field named query ID. And when the client receives such response, it will extract the query ID and use this query ID as an input of the NAP map. Then the server will know that these two resources have some correlation. Here are some other considerations when designing the path vector. The first one is to consider the compatibility with multi-cost. We suggest that path vector is never a testable cost type. Here are two meanings. Path vector must not be included in the cost type names, testable cost type names, or testable cost types. Testable cost type names is a field provided by the server to indicate which cost types is testable. And the testable cost types is included by the client in the request to indicate that what cost types I am going to have a test, but not included in the returned cost. For server who didn't specify the testable cost type names, and for clients who didn't specify the testable cost types, the client still have the chance to add some constraints on pass vector. So the second idea is that the server should judge whether the client tries to add constraints or all constraints to the pass vector. Once such situation happens, the server should return an error message. The second consideration is the time to live. Since the network elements in the NAP map are generated dynamically, so such query-specific network elements will consume resources when these elements are cached. So we need to set a time to live to remove outdated data. Finally, here are some discussions to be mentioned. First, how could we provide cost calendar for pass vector? Should we provide, since the pass vector actually includes two resources, so shall we return the cost calendar for the filtered cost map or endpoint cost map? Or maybe we should just provide a calendar for the pop map alone. The second issue is that there are some snapshot and real-time update problems. Query-specific LNE properties are likely to be snapshot and hence no longer updates in real time. To illustrate this problem, we use an example of the query flow. First, the client will send a request of the FCM or ECS. Then, the server will return the FCM ECS response. Meanwhile, the server will generate a NAP map with the query ID information. So we suggest that this is a time one. The ANEALL001, the properties delay was generated, and at the moment, its value is 10. Then, after the client receives the FCM and ECS response and got its query ID, the client will use this query ID and the corresponding network elements to query of the NAP map with the query ID. Then the server will return such information with the query ID. However, this time, when the client sends a request to the NAP map, the real-time delay of the network element L001 changes to be 30. But actually, the server will return the value of 10. So it's a snapshot and the real-time update problem. That's all. So, any question?
Could you actually go back a few slides to the example that you had? More. One second, let me do it from here. Yeah, here. Could you explain the request response interplay here, because I'm not quite sure I followed.
Which one?
Starting from the request that we see at the top left.
Top left.
Yeah.
Okay. The request format of the cost map is the same as the base protocol, right?
So, I mean, you have a query ID, which is a new element added. So the server puts the query ID in the response.
Yeah.
And the client uses the query ID again later in a subsequent request?
As we all know that when we ask for the cost pass vector, we have to retrieve two resources, right? The cost map and the NAP map. So the query ID returned by the cost map is for clients to query information in the NAP map. As you can see in the top right is an example of the NAP map request. The client will use the query ID returned by the cost map. They are the same query ID.
Can I just add, sorry to add that. So basically, the query ID return first one in this path vector query. So therefore, one part respond to the query ID, and then the first round is you return the path vector, for example, on the lower left corner, and you have all the path vector. For example, from page 1 to page 2, you are going to traverse two network elements, but the question now is how do you really get the properties of those two network elements? For example, ANEL01 and ANEL02. And then you need to issue the second query. So therefore, on the right upper corner, there will be second query. And the query now, you send the query, but now you really need to indicate, because those network elements, we don't want to assume they are unique, in the sense that we don't want to say, oh, across all these path vectors with all these abstractions and virtualizations, you always have the same unique name. And therefore, we must say, hey, in which context, for example, the query is, I want to know the properties of ANEL01, ANEL02, and so on, and property is available bandwidth, but I want to know them. But the other service, network element property service, you need to provide, oh, okay, you tell me which context, otherwise I don't know what it is. Therefore, now the query ID will be as part of input parameter, and then you can get all the results back.
So then inherently, the query is temporally scoped. In other words, does the server delete state if it doesn't get a query at some?
That's exactly the excellent point. So basically here is, it really depends. And for example, one way to do, yes, so to short answer would be, that would be implementation. And because, for example, the server could really, for example, in some simple setting, for example, the server is really, for example, highly dumb in the sense that all the path vectors are just essentially static information anyway, because they have the internal, for example, routing information, all the network elements are statically computed anyway. Therefore, the server will not need to delete any information. So therefore, those NE01, they persist forever. So therefore, whenever you query, they can also do that. But then the server could also on demand, on the spot, to generate abstract elements, because this guy is not trustworthy or whatever this agreement, I'm going to abstract all this stuff away. But then you need to really know which contact information was queried. So therefore you do that. So therefore you do an internal query, internal caching, and then you delete it problem. You have a time to live, for example, a few minutes or what, let's say your internal implementation. And Don did mention that we're planning to add a new field called time to live to really give a client, for example, say meta v tag is query ID this one, time to live is this long. If you don't query by this line, time essential, then you still get path vector, but the network element property will be gone.
So you might also have to update the alto error codes to account for the fact that you might do a query with a non-existent or deleted query.
Yeah, well, I guess that's an excellent point. So one way we can handle is it's still essential the resource does not exist anymore. So therefore, we return the result is now. But of course, probably more explicit good design is tell them, look, this data essentially expired. We're probably good point. So we can add, for example, a new error code. Excellent comment.
Thank you. So I think, yeah, go ahead.
No, I have no comments. I think what we discussed in the beginning is that we think as chairs, this is the one item that is targeting the graph representation. And you were mentioning this before, and it's been around for a while. And as we want to make progress, we think we should hum, right? So we're going to take a hum now. First, I'm going to ask who's in favor of adopting the latest version, which is, I think, the 0.4 version of the path vector document as working group item. And then I'm going to ask who is not in favor. Okay. So if you're in favor of adapting draft Yang alto path vector as a working group item, please hum now. If you're in favor of adopting it, please hum now. Right? That was my question. Yeah, because I was, sorry, we have to start this over. I think people, maybe I confused people. So first I'm going to ask who's in favor, then I'm going to ask who's not in favor, right? So if you're in favor of adopting draft Yang alto path vector as working group item, please hum now. If you're not in favor, please hum now. Okay, So maybe it's very quiet. I didn't hear anybody humming when I asked not in favor, so nobody's against it. But the humming for in favor was a little quiet here to hear. But we are not so many people in the room, so I saw consensus.
Yeah, I mean, I think given that we are about 14 people, 15 people in the room, I think the hum was consistent, I guess, unless we want to hum at the top of our voices. Nobody said anything against it. There is no other draft in this space. So given all those things, we will most likely adopt this as a working group item. We will take it back to the list and ratify it there. But unless somebody comes up with good reasons to tell us why we shouldn't, we'll proceed with it. Yeah, for the folks on Jabber,
I'm just checking. No.
okay, so silence implies consent on Jabber. All right. So
Yeah, I mean, obviously we're going to confirm this on the mailing list. So,
Right.
but we just want to get a feeling in the room. I thought it was positive. It was not very loud, but yeah. Okay.
okay, excellent. And again, this is a very important draft because this is one of our main, when we rechartered the last time through, this was one of the main reasons we wanted to recharter. So it is very important to get this work completed.
Yeah, I do want to add one comment, and this is important. I believe important piece of work, and also I do want to mention that this is also one of the much more complex piece of work because it really involves substantial, for example, abstraction, topology, and so on. So any feedback from other people or even people who are interested in working together will be wonderful.
Right, that was Richard at the mic. And Richard, please, drive this forward, with as many cycles as you can spare, in between the meetings.
Sorry to team up. So basically, I think our goal is the authors. We do have several authors that are very motivated, and our plan is get a pretty relatively complete version probably within a few weeks first, and then post the mailing list. Of course, final go across the next IETF.
Excellent.
So next up is traffic optimization for exascale science applications. And we are actually on time.
We are on time, yes.
As always, I should mention.
We're 3 minutes ahead.
So this is the pointer. Okay. Good morning, everyone. My name is Qiao. I'm here to present our draft on traffic optimization for axial science applications. Our vision about this project is that with the exponentially increasing volume of data in science programs, and we want the resource distributed in the global-wide science network should be orchestrated flexibly, so to meet the demand for the exercise science applications to analyzing and understanding these data. And the goal of this project is to push towards production deployment for a series of intelligent software-defined global resource orchestration system for data-sensitive science programs. And this will be a game changer for the next generation science data flow orchestrations, and it will shape the whole architecture and the operation modes of the future science networks. And this is a collaboration between multiple organizations, including Caltech, CERN, Tongji University, and Yale University. This is our internal project timelines, and we are currently doing pre-production deployment for the implementation and deployment for a couple of system prototypes. And by the end of this year, we should be able to finish that. And then for the next year or 18 months, it will move forward to production deployment in several different universities and organizations. And for the next 5 years, we are going to push forward for the worldwide deployment across the whole global science networks. So a little bit background about the context we're working on. This is basically the Large Hadron Collider deployed in Europe. It basically generates data at a very fast speed when it is on. And basically, the raw data is generated from the collider at the tier 0 site deployed in CERN. And after the raw data is generated, it takes couple of filters to generate reconstruct the data and LD data sets, and these data sets are later being used, are later distributed to tier 1 sites across different continents, and these data sets will later be used for different science applications to analyze and and also to run more multicolor simulations. And this is the settings of this science network is basically because it's a multi-organization collaboration. It's essentially a multi-domain data center networks, which is not seen in commercial data center networks. Which in commercial ones is basically just Google or the Facebook that are running one single administration domains, and because the different sites have different capabilities, they provide different they have heterogeneous resource and system provisions, and in these science networks there are also different applications and data analytic jobs. And last time we talked about the large data set transfers, but this is only one jobs in the science networks. And MapReduce and MPI are the very two popular examples, and we have so many others going on. A takeaway from the version 0 in IETF 1996, back then, our system proposed to use auto topology services, including the path vector just adopted, and also the routing state abstraction to provide on-demand fine-grained network informations, and so that our central scheduler can use such informations to decide to schedule the transfer of data sets between different sites. We have the prototype implemented with Caltech, and we do a demo on IC16s. Videos can be found online. And this prototype is currently under production development with CERN. And some updates. The update in this version of our draft is that we make an argument that data transfer is only one application in CMS, and there are so many other data analytic program applications going on in the program. And the Auto not only has a potential to improve the performance of data transfer applications, which it was originally proposed, so it also can improve the performance of data analytic applications. And the one observations we found that in data center networks, when you are doing data analytics, network resource is not always a bottleneck, and sometimes computing resources like CPU or CPU utilizations, or sometimes disk I/O can also be bottlenecks for affecting the performance of data analytics. So in this draft, we propose EXO, a multi-resource orchestrator for CMS applications. And the reason we submitted, we feel this is important to the working group is because EXO is basically a representative auto application for data center networks. And in the charter, data center networks is listed as one major use case, but we haven't seen a very active draft regarding this use case in the working group documents. And we expect the success of this system to provide key insight and experience about how to deploy auto service in data center networks and developing more generic auto applications. The overview of our current in the current design is that we deploy auto clients and servers at different sites across the whole world, and these clients may basically make on-demand queries to retrieve endpoint properties and the polity informations in the network. And using this having acquired such informations, we make a proposal that we expanded the capability of the so-called abstract network element concept, and originally proposed in auto RSA and path vector, and we use this ANE to encode to provide an abstract view of not just networking resources, but also including computing and storage resources. And with such abstract view, basically we can provide deep site orchestration between different clusters, storage system, and subnets to successfully co-schedule CPU storage and networks to improve the performance of data analytic applications in CMS network. This is the whole system architecture. Suppose we basically have different data centers, and as I said, these data centers belong to different administration domain, and we have a logically centralized job parser and multi-resource orchestrator. And at each data center site, we essentially deploy two types of applications. The first one is resource abstraction agent. We will discuss about this in detail. Basically, it provides resource information, query, and response functionalities. And the second agent is the task execution agents. Basically, it will perform the resource authorization decisions at the different centers to really execute the data analytical applications. And here is the detailed workflow of the resource abstraction agent. Basically, the logically centralized resource authorizer will send the input dataset name for the analytical job and the related job information to a resource locator. This, in analogy, we can understand in current CMTS networks, we have these LFN to PFN mapping agents, which means basically we can these agents basically can decide that given a dataset name, where this dataset or what are their files stored at different particular end hosts in the networks. And so basically, after locating such information, after finding the location of the datasets within each data center, and the locator will talk to a resource management system, such like a Yarn or HTCondor, to get that what would be the available resources allocated to this job if this job is to run on this certain data center. And with such information retrieved, the locator will send the endpoint address of available resources to the auto client, and which will issue queries to the auto server to get the endpoint properties of the resource node, for example, the computing node and the storage node. And in the meantime, because it is possible the computing node and the storage node are not physically connected, are not in the same rack, or may even belong to different clusters. And the other client will also issue a path vector-based query to get the properties of the network resources connecting these to end host. And after the auto server returns such information to the auto client further sends this information to another component we call ANE aggregator, abstract network element aggregator. This aggregator, we currently put it outside of the scope of auto because we figure it's a more modular design. This aggregator is basically in charge of further encode the endpoint properties of different computing and storage node, and also the network resources encoded in already abstract, or earlier ANE into one single ANE abstract network element, and basically it will provide a more abstract view and send it back to the orchestrator to make scheduling decisions. And the most important component right here in this system currently is this ANE aggregator. The motivation we have is in Yarn or HTCondor. Basically, use this core screen resource information, like how many cores and memory will be allocated to a certain job. And we feel like this is not the correct way to go, because this is core screen information, and it has been shown using data tree studies that many different resources have almost equal opportunity to become the bottleneck of the data analytical applications. So the basic idea for us is to abstract the computing, storage, and networking resources allocated to a certain job into a single ANE. And in this ANE, basically each resource has certain properties, and these properties can be encoded into the property of ANE. And similar properties like the I/O bandwidth and the network bandwidth, such properties can be merged into a single aggregated property to reduce the information overhead and privacy exposure of this abstraction. And here is a very simple example here. Basically, suppose we have one storage node, one network link, and one computer node, and each has certain property called like I/O bandwidth, block seek delay, and data transfer delay bandwidth, and memory bandwidth. And basically, essentially, we can encode them into one single ANE with a data transfer delay, which is a minimum of all three bandwidths, and a generic delay property, which is the sum of seek delay and the network transfer delay. And basically, this property merging and aggregation idea is originally motivated by path vector and RSA, and it is crucial for privacy preserving. But we feel that it still lack of a rigorous analysis about how much information it will expose. So this is something we are working on right now. The design choice we have made is that we use ANE instead of PID, and the reason is because we listed here PID is relatively static abstraction decided by the policy of size, basically try to aggregate different endpoints together, but with data sets deployed at different places and with various data sets and heterogeneous resources, ANE is a more dynamic. That provides a more dynamic abstraction which can be decided by not only size but also applications such as data set name, the properties of different jobs, and the preferred resources. It's a more dynamic and flexible abstraction. And here is an example of how we use such abstraction to make resource authorization decisions. Suppose we have one single job which needs data set X as input, and we found that both data center A and B, probably one in Europe, one in North America, they each have a copy of X. And the resource allocator in A found that if we deploy this job J into our data center, it will be placed on a different node from X storage location, but though both nodes will be in the same rack. So after requiring the endpoint address of the storage node and the computing node, our auto client will first issue a EPS query of a storage node. Basically, we got the IO bandwidth and the seek delay, and it will also issue a computing node the endpoint property query for the computing node to get to request for the memory bandwidth. And after that, we follow the current design of path vector. We make a path vector based. We first make a path vector based ECS query to get a network calls between the source and the destination, the storage and computing node. And with the return, we have a cost map which showing us, okay, this is abstracted into one single abstract and network element called L1. And we also have this query ID, which is to provide a reference to that we can get the property of this abstract and network element. And with that, since we further submit a PV-based abstract network element property query, and by specifying which query ID and which is the entities we want to query and also the properties. And so essentially we get the response property map with the bandwidth and delay we required for the abstract network element. And then after all these three results are retrieved by the auto client, we have our ANE aggregator to aggregate these three things into one single network element. We call it A-J-X, and as we showed earlier, it's basically have a data transfer bandwidth and also a delay. So this is like if this job J is assigned to data center A, and this is basically like we can envision it like a VM because that. And similarly, because in data center B, because the locator found that okay, the storage node, the job can be assigned to the same node where X is stored. So in this way, we only have one endpoint, and we only have one endpoint. We just basically transfer it to use AE aggregator transferring into another abstract network element, so that we don't expose the real information about the data center. So we preparing this AEB-J-X and the one ANE-A-J-, we found that B is we should place this job on data center B because it provides a better data bandwidth and a lower delay. So the design issue we are currently the design choice we make right now is that we put AE property aggregations outside of Auto, and it is true that it is originally motivated by auto service RSA, but we think basically how we encode abstract different resources and the property of different resources is very dynamic and application specific. It can be specified by application of the preference of applications and also the policy of the size. And we thought about put it as a part of new auto services. the advantage would be that you will enrich Alto's control capability on privacy leak. Basically, what kind of information we can return to the application, in our case, the resource attributor. But the concept, we thought Alto is supposed to be orthogonal of applications. You should not ask for too much application-specific information about. So our current design is basically only let the resource locator pass the endpoint address to AutoClient, and AutoClient do the query to the server and return the result to the ANE aggregator, which work as an independent module instead of auto service. And we are exploring. We feel like this is the correct way to do, but we'd like to hear feedback from the working group. And after this ANE aggregator calculated calculated the abstract view of computing, storage, and networking resources, we send this information to the multi-resource orchestrator, which deploy the online algorithm to make the orchestration decisions, and then send back to the task execution agents deployed at different data centers to to enforce the resource allocation decisions. And these are basically the application of a typical application scenario of Auto. And the Auto provides fine-grained resource information using encoded in ANE to improve the performance of our system. So to summarize, basically in this draft we propose the Encode, which expands the capability of abstract network elements to provide an abstract view of different type of resources, not just networking. And this will provide support to efficient resource allocation for data incentive applications. And we are also looking at the feasibility of applying cost calendar, flow cost curves, and other possible type extensions in the working group to support the next generation science data flow orchestration. And the milestone, like we showed that at the beginning of the talk, we are currently doing production deployment of EXO, and we hopefully finish it by November, which also IETF 100, but also supercomputing 17. We are going to do a demo in that conference. And also we plan to finish the production deployment by IETF 102 and 100, between 102 and 103, which is supercomputing next year. So I think here I finish our presentation. I'm happy to take any questions. Thanks.
So this is pretty well fleshed out than the previous presentations.
Yes, we feel like data transfers in certain ways only one particular applications of the whole science network, and we feel that we can using this yet. So we can still encode data transfer into one particular application types in our frameworks, and we feel this more generic and will essentially change the whole architecture for the science networks.
So I'll let Lyle Burtz go ahead at the mic and.
Lyle Burtz, Sprint. Just a question for you and a question to the chairs. So in this production deployment stuff, is this on a path to open source, or is this something that's going to be available later to third parties?
Okay, so let me answer. I'm Richard, and so this is a collaboration basically between Caltech and Yale and CERN. And I believe the goal is we're going to, the main context is right now because LHC, they're trying to substantially, I think phase 2 or phase 3, they're trying to go to exabytes. And therefore, substantially more data to be transferred and more data to be collected. I believe intentionally the moment is to make it open source and to make it really available. Of course, the system will be running on top of many other data. So this will be, the system we're building, I think the first author is called Justus, and his part from CERN. And the system called FedEx, I think the goal is integrated with FedEx and then released to the open source system, at least for that part.
And then a question, or maybe just pointing out an observation to the chair. So this is aggregation, again, not for the first time or last time. And I know that I've talked about aggregation. We're starting to see more of the benefits here. I would just lay it out there that maybe either we have much more direct milestones to aggregation, because I just don't think Alto can scale, or I should say the Alto servers themselves can scale. I think the protocol and the infrastructure is just fine. But at some point, I think we're going to have to kind of face the music and maybe look at aggregation as one or more milestones. So what I would say is, for your proposal, I wouldn't propose that we just look at A&E aggregation, but we just look at aggregation in general.
Yeah, I mean, that's what Jan and I were discussing here on the sidebar. I mean, this is clearly interesting work, and you have expressed interest in it, and obviously it's of interest to the high energy physics community. The question is, you know, how do we work it into our processes such that there is something tangible delivered at the end? So I don't know. I mean, if the working group, so first let me ask the working group. I mean, for the people here and for the people in Jabber, how many of you have read this and find this interesting? So how many of you have read this? Okay, there's about 5 or 6 hands here in the room. And how many of you find it interesting? Same 5 or 6 hands. So considering there's like 14, 15 people, that's almost half the room. So I guess Jan, I, and maybe Miria, we can talk to you to see how, if there is enough interest in this, how to move it ahead, within either the current charter or by adding milestones.
Well, the other observation I'd say, right, is we have a lot of things in the queue. So getting those out of the way. I mean,
exactly that.
It's not as big of a deal to me if it's a milestone and we defer it in lieu of clearing the queue. But I'd like to see maybe something up there on the charter to at least start the investigation on this.
Yeah, absolutely. Absolutely. We do have to first finish what we have started. But clearly this has been coming back for the number of IETFs in the past. And this, to me, when I saw it, was more fleshed out than it has been in the past. Sabine.
Well, this also relates to Light's point on aggregation. We see in those use cases that definitely we would benefit from having several auto servers that work on several scopes. So that would help making it scalable. But of course, yes, we need aggregation and we need something that somehow puts all that together, or that stitches the result of auto transaction together. But definitely, this is yet another, this is one of the interesting points. It's yet another use case that claims for having heterogeneous auto services working together.
Excellent. For the minutes, maybe we can just reflect that there is some interest in doing something with this work, doing something we can flesh out on the list, but there is enough interest that we want to do something with this work after finishing the current milestones first.
Yeah, may I just add 2 quick notes? The first one is the materials we give the slides is different from what we submitted 2 weeks ago. So we'll update a new version in a week or so, and we hope to engage more active discussion with working group members. And the second note is that scalability, like Sabine and the chair and the whole group agree, scalability is indeed an issue. I do want to point out privacy is another concern that which hasn't been clearly addressed by RSA or PathVector in the current draft. And well, I'm a postdoc, so I'm doing research on that. So I would like to focus on that a little bit and hopefully to make some progress by next IETF.
Okay, really short because we are 3 minutes behind schedule.
Okay, so in the summary, you plan to apply cost calendars. So I would be interested, I think it would be interesting if you could bring an example, a concrete example of a metric of what type of schedule and attributes it may be nice adding this in the draft.
Yeah, absolutely. We can discuss it offline a little bit, but yeah, using cost calendars, well, it may not. One very simple use case is that when different clusters are trying to do the job, even doing that at different times, the cost is different because one important is they are very the energy consumption is high. So basically, it consumes lots of electricity, and the price of the electricity is at different times, it's essentially different. And basically, if we have a cost calendar, we say, okay, this job is not that urgent. I can have it run maybe in midnight so that I can sleep and get the result in the morning. So I don't have to schedule it in the evening or morning where the electricity price is very high. This is a very quick example, but there is also other examples regarding the cost. I believe that it is cost calendar. So basically, electricity cost is one, and the other one is talking about because it's essentially a multi-domain. So every domain is basically paying by themselves, and they are getting grants and try to contribute. And it's also related to maybe the one area bandwidth cost. And so these are very two quick examples. But we definitely need to finalize a very concrete and very concrete and very real examples very soon. Thanks.
Okay,
Can I make a very quick comment? So because
very quick.
yeah, very brief. So for this work, because basically is, for example, next IETF will be in Europe. I believe it's in Prague, right? And we do have a large number of people from CERN there in Europe. They, I think if we have some interest, they're probably very easy. We can organize a large number of people show up from CMS, from HC. Probably can be very helpful to see how they really like, because somehow they're driving a lot, the very large data, real-time analysis can be quite interesting.
Sure.
Okay, so thank you, the chair. Thank you, the working group members.
Thank you. So next up is Alto extension flow-based cost query.
Yeah, hello everyone. I'm Jensen, and I will present the update of the FCS draft. And maybe you have noticed that we have renamed the our draft name from the flow cost service to the flow-based cost query. Why? Because we want to solve some more general problem. Actually, this problem has been proposed since IETF 94, and we have two drafts to discuss about this problem. And so, what's a cost query? In our legacy auto protocol, we define several services, and we think the cost map and the filter cost map and the ECS are the cost service because they are used to provide the cost riders. We think a service is a query service if this service can accept a query input in its request. So I think the filter cost map and ECS is a predefined cost query service. But now maybe we need to some new cost query schema. So we define it flow-based design for the cost query schema. We have introduced the two different motivations. We introduced it in our IETF 96 meeting. The first motivation is about in some use cases, for example, the co-flow scheduling, we need to solve the flow relationship. Because if we use the legacy auto protocol, we can only product the flow, the cost query in the core product schema. But in some use cases, we need to provide we need to query some individual flows, and these flows have some correlationship. So we need to extend the query schema, and maybe we have two solutions. One is to augment the existing request, and another we can introduce a new media type for the request. But we think the augmentation maybe is a backward compatible solution. And another motivation is from the fine-grained routing, because in several new network architecture, for example, in SDN, in the open flow network, the flow may be fine-grained. So in these use cases, both the request and the response will be affected. So we think we can maybe we can introduce a new service to solve this problem. But if we just introduce a new code service, maybe it's not extensibility, not extensible. So let's think about why not introduce a unified service if we can. And we have read two drafts to discuss this problem. One way one is to we define the ECS flow extension to solve this problem, and another we define the flow code service. So in our recent update, we marked them as one draft. We claim the ECS flow as a basic flow-based query design, and the flow code service as a advanced flow-based design. So to provide the flow-based code query, the following is some key issues we need to solve. The first one is how to encode a flow. So in our design, we have two solutions. One to use the traditional encoding. We just use the source and destination to encode a flow. It should be backward compatibility. But we also provide a solution to specify flow use the flow attribute object. It needs a new specification to define the flow. The second issue is about because we introduce a new flow, a new code query schema, so we need to declare some new capabilities. As far the first one, maybe we need to provide the capability for the support of the flow based query, and another one we need to support which flow attributes the server need to the server can provide the server can support. And if we if the server wants to support some more general maybe some customized flow attribute, a server maybe the server need to specify some type length value dependency of this flow attribute. And another issue about we need to re-encode the query schema. We have several we have two different solutions to solve this problem, and the last issue about how to handle with multi-path problems. It is a very important issue, and we will discuss about it later. So this is an example. We provide two different flow encoding. The left side we introduce a basic flow encoding. It's an augmentation of the design in the ECS. In the ECS, we have we use the source and destination to query cost value, and the source and destination is a tapped endpoint address. It can be IPv4 address or IPv6 address. In our extension, we just augment the syntax of the tapped endpoint address. We use an endpoint URI to extend the syntax. And you can see this example. And in the endpoint URI has three parts. The first part is a protocol part, and the second is a address, and the third part is an optional part. It makes the client specify the TCP port or the UDP port. And for the advanced flow encoding, we have introduced this then in the IETF 96. It's for the design the flow call service. We just specify a flow by a flow attribute object. So this is the design about how we provide the capabilities and the query schema. The query schema is a schema of the service request. So also the left side is about the basic flow-based design, and the right side is advanced flow-based design. And you can see in the basic flow-based design, we extend the capability of the cost map, filter cost map, and filter and ECS. And the filter cost map or ECS need to specify whether it can support the flow-based filter, and also it need to specify which protocols the server can be support. And in the advanced flow-based design, it's in the flow call service. The flow call service is a new service, new auto service. So it don't have to specify the support for the flow-based, but the flow call service needs to specify which flow attribute is a required attribute, and which is optional. So multipath issue is a very common issue because it exists for both flow-based design query and non-flow-based query. After we have provide the flow-based extension to make the client can send some expensive flow encoding, but this issue is still exists. So we think about 3 different solutions to solve this problem. One, we can introduce a statistics object to specify the cost value. But this solution may be not be the path vector. Another, we can list all the potential paths. So in this example, means there are 2 different paths matching the same flow specification. But it's a little complex if you make it work with the multi-cost extension together. Another one, we can throw a warning in the response data. We just mark a signal, for example, MP string means this value is multi-pass, so maybe you want to respecify your request to make your request more fine-grained. So some other considerations about how to define the error handling message. In the right part, it's about in the flow call service, we define 3 types of the error handling message. We define the flow complete, missing field, and the missing field means the request missing some required flow attribute. and also the unsupported flow attribute. And in the basic flow-based design, the basic flow-based extension does not have to specify the missing error message, because in the query schema has guarantee all the required flow attribute has been specified.
Yeah.
Okay. Okay. So following, I just want to open some interesting discussion about some common issues. The first one maybe the first one about who would prefer to make the flow definition. In our design, we just use the client define. It means the client specify the flow definition in the request. But if the server can provide some customized protocols, so the server maybe need to provide the table length value dependency of the flow attributes. So another idea is about how about we use the server defined. For example, we can use a unified property map to provide which flow is supported in server. So it conduct another issue about how about we use the unified property service to define the flow-based query. So there's some idea about it. So maybe we can define 3 types of the property map to produce this solution. So the first property map to define the supported header field and table length value dependency, and the second property map to define the supported flows, and another property map to provide the flow cost values. And you can see the last property map will depend on the second property map. So another general idea is about how about we introduce a general query merging them across the resources. So this here is an example about it. Because of the time limit, maybe we can discuss about it in the mailing list. Another problem is that how about we define the flow aggregation? Okay, flow aggregation about the.
I think we do have to wrap up. I'm sorry. We have 2 more presentations.
Okay.
So do you have a final slide where you have future work? Yeah.
Yeah, that's the last page. So we are implementing the prototype in the OpenLight, and some next step maybe we are considering shall we merge some solution into the path vector design, and
maybe take
yeah.
a quick comment if there is at the mic.
Yeah.
Yeah, comments? Who has read the document? Yeah, obviously.
Thank you.
So I think we need to take it to this.
Yeah.
Yeah. So any other comment?
No. So there has been some discussion on the list, and I think merging with path vector, I think as chairs, we would have no problem with that. I guess that's up to the authors to decide if how complex you want to make the path vector document.
Sure.
Yeah.
So very quick comment would be probably unlikely to merge with path vector fully, because otherwise this is a very complex piece of system design. So therefore, if we make a fully flow-based for path vector, probably slow down path vector substantially.
Yeah.
So very likely with simple version like it down presented.
Okay.
That's fine.
We need to take it to the list at this point.
Okay.
All right. So next presentation is extensible property maps. Richard, I think that's you.
This is something that we would like to hum for
Right.
adoption. So, Richard, leave at least a minute or so for that. Towards
Sure,
the end.
I will try to be very fast and sort of like we can squeeze some time. And so, and here is a document extensible property maps for the auto protocol. And I don't want to even though I'm presenting it, but I'm not going to claim a lot of credit because basically Wendy did most of the work and she's wonderful. But we do make quite a few changes lately. So here is the high level to summarize what we've done essentially from last IETF and to now is there are two versions submitted. And if people read it, so there's one version submitted is March 11th. Mostly it revised of structure from early versions. So therefore, most structure-wise, we don't see much change about the technical content. And then in the meantime, I got a lot of actually small feedback from a lot of people on stuff, so there are all the small emails. Therefore, I took a liberty of on March 28th, I believe, and I did a lot of small edits for the earlier version according to all this feedback. For example, clarify longest preferred matching would be because oftentimes we have properties. The problem is, for example, look at for people who are familiar with programming languages, and the problem is all this big fight in programming language community is and object property inheritance. So therefore, when you have C++, you allow multiple inheritance, you get into all the mess, and therefore eventually when you go to Java, it's single inheritance. So therefore, there are all these issues raised to me. You have we're designing a property framework. How do we really handle that part? So therefore, I was trying to clarify, for example, the qualification would be longest preferred matching actually beautifully enough that it would not lead to all these kind of like potential issues. And I do want to mention, for example, in the newer version of March 28th, and if you read the document, you look at the newest version, and if you just search it, and you can see a few places marked as to do, because we do have a few places where we want to clarify the point. Even personal, I think actually the document pretty mature for a while, but we still found several places we want to do, and we're going to resolve them probably quickly after IETF within a couple of weeks. And the goal is essentially to really get some more discussions to really finalize, because even though I think that's pretty substantial and stable, but my main concern, and also when this concern would be, what if there's some key design points and people don't fully get, and therefore if there's some issues. So therefore, what we did during essentially to prepare for this IETF is we did a very short email, and we posted to the mailing list and asked to summarize all key design points. So therefore, for people to really give very quick feedback, even if you did not read the document, we still want people to read it, to know the key design points. So therefore, even for today, even if you did not read the document, you probably can still make an informed decision. So that's the main purpose of why we did that. Not to really, for example, preempt and anything, just let people know all the key points and pros and cons, even for these key design points. So here, let me just very quickly summarize all the key design points. If you read the document, of course, everything will be done and everything will be clean. And if you don't, and here will be very quick, some of the 3-minute summary of the key design point, just in case you object to this one, probably that's a good point to raise the point right now. And number one, of course, the goal is provide properties to all kinds of entities. If you disagree with it, that's probably a very important design point. So therefore, we really want design for all kinds of design points. So that's design point number one. And number two is we have the scoping, which is very unique rule now, is every single entity we're going to provide and confer entities would be named as domain and name. Domain can be IPv4 and PID and ANE and so on. So therefore, essentially, it's domain and the name structure. So we feel that this is very extensible because you have domain later, for example, you have other domains, you have special structures, therefore you can always handle that. So therefore, that's the one reason we do that. So if you have a point about this one, probably you should really tell us. And then essentially one sticky point which was struggled for quite some time always, let me summarize, I think that's one we also modify a little bit in the document as well, is there are 3 types of entities which you're gonna see. And once global, they are beautiful, they're easy to handle, and essentially the whole document handle them very nicely. Is IPv4, IPv6. What's an entity? Essentially, it's domain IPv4. You give an address, they're unique. You can really give them property. That's very easy to define. Like the document, this part, I believe, is very well done already. And number 2 is the hard part. We have a lot of discussion on that part. I think the document right now, a major part of a complex document comes from this part. Is some the entities are defined essentially depend on some information resources. For example, PID will be depends on a network map. If you don't give me, for example, which network map you have PID1, PID2, I don't know really which one you're really referring to. They are not global unique. And therefore, we really spend quite some time to really make sure this one is proper to handle that part. And last one is essentially the most difficult part. I think Don handled this one in the past vector, but that's essentially the dynamic entities. We start to write a little bit sentences there and there, but our major decision is we probably will not handle this one in the most generic sense for this document to really make progress. So if you have any point, question here, you should read the issue here. And number 4, design point, which we want to emphasize, and that I believe some people might have a potential concerns and so on, would be we really want to emphasize that we want to allow aggregation of entities. Even though you want to create properties of entities, you probably potentially is you only talk about one at a time. And we really think it's very important that we want to have aggregation. So therefore, we want to allow essentially, for example, IPv4, and you can have a prefix instead of, even though we said a domain and entity name, it actually is not. It is essentially domain and set of entity name. So that's a major design point. Like I said, the potential price we pay is then you can multiple inheritance. The benefit we have inheritance. The price we pay also will be potential that we introduce inheritance. So therefore, we decided to take a bullet. The current document, which has been stabilized after IE196 already, is we go down this path. We feel that's beautiful, that's scalable, substantially increased scalability. But if you have issues, and that's probably issue you should really raise. And I want to read the last point, which is also, I think, related with quite a few documents here, and we want to get people feedback. That was also design decision, very well written in the current document. Its property names are in a single global namespace. You could imagine autonomous design it's not. For example, namespace, essentially property namespace would belong to in for example, domain. And IPv4 would have set of properties, IPv6 would have set of properties, and PAID would have set of properties. Our decisions, no, we're not going to do that. And we are going to use a single global namespace. And the main reason is we want to enforce consistent usage of all the property names. If it's called latency, it always has the same meaning. And of course, in some different domains, the interpretation can be slightly different, but we want to enforce that one. So that's a major design point which conveyed in the current document. So I'm not going to go over the stuff. There are a few, for example, small issues we are still solved. We already have them, and I think we post them in the list, I believe. And also, I want to really, even though, for example, I think today is one make a decision to go on, but I do want to mention, for example, a bunch of small things that we want to plan to revise. Therefore, just give you a full disclosure about all the information you might need. And for example, 2.5, and we want to really emphasize that it's unified property name. We want to emphasize it greatly. And 2.6, actually, we are trying to restructure the document a little bit, and because 2.6 mostly talking about dependencies about property maps and so on, we want to go beyond network maps. Therefore, we want to restructure a little bit to a later section. We want to there are a couple of sentences which I want, for example, 3.13 is want to clarify essentially no multiple inheritance problems and so on. We want to add a couple of sentences, and 3.1 I think that's okay. So 4.4 is we want to emphasize you can have multiple domains and even in the same property, and we want to have allow multiple uses as well. We want to add a few sentences to clarify if you read document. There are a few places, oh, what if you have multiple domains, you have multiple uses, and we are planning to add a few sentences to clarify. I think those came from the feedback. I got quite a few feedback from other people. And also there's one place feedback for people who read would be essentially is, what's the meaning before, if a property, for example, latency, you do not provide it versus you see the value is now. So what's the meaning of, how do you really distinguish? For us, I mean, if you don't define it, there's no value, it might have a value. If you say it's now really means it actually does not have value, it just, we cannot even define the value for this one. So we're trying to clarify all this stuff. That's pretty much it. And I essentially will stop here. I believe that's very well, because this has been quite stable for a while, so therefore I don't really have a lot of substantial changes. I don't think Wendy and I plan to make substantial changes, so therefore that's why mostly this is summary of main design points.
Thank you, Richard. So as Vijay and I have been mentioning before during this meeting, we think this is the mature document that addresses one of our main milestones, and it's absolutely needed also for other documents,
yes,
as you were pointing out. So since it's basically the only candidate we have at this point in time, we would really like to adopt it as a working group item, or we would ask the working group to do to make this decision. So again, I'm going to ask Aham. First, I'm going to ask who's in favor of adapting, and then I'm going to ask who's not in favor of adapting. So if you think that the document draft Rome Alto Unified Props New should be adopted as a working group item, please hum now. If you think it should not be adopted as a working group item, please hum now. Okay, so again, there are not a lot of people in the room. I heard people humming in favor of adopting it. I heard nobody objecting. So that's rough consensus. We, of course, will confirm this on the mailing list, and maybe other people have comments. But yeah, there were no objections here, and we heard a couple of hums in favor. Okay. So I guess it's me.
Yep. If anybody has any comments on what Richard presented, please come up. Otherwise, I'm putting up Jan's slides.
So I mentioned this in the beginning when we started the working group. We have a new milestone, which I think our area director still has to approve, but I upload. You did, just did. You found the button. Okay, thank you very much. So yeah, this is kind of a leftover from the CDNI working group. So we split the footprint capabilities interface in the CDNI working group into basically two documents. So one is the specification of the core JSON object, and that is RFC 8008. That's done. But that RFC says nothing about how to get these JSON objects from A to B. So we need a transport service, and the CDNI working group and lots of people have decided that this should be a new Alto service. And so we thought it was much more appropriate to finish this document in the Alto working group, because we basically need to decide what is needed for this new Alto service. Where is it exactly as the traditional Alto with respect to error handling, for instance, security, and how is it different? So this is added as a new milestone. There were no objections. So I just want to give you an overview of what kind of JSON objects we're talking about. In the Alto working group, we are very much used to network maps, cost maps, and today we've seen much encoding. So this is an example of a JSON object from RFC 8008, so a CDNI FCI object. Here a CDN would signal to another CDN, oh, well, as a delivery protocol, I support HTTP 1.1, and then it could have several footprints, and the footprint could look like here, like you see here in the bottom, some, IPv4 CIDR notation, slash notation addresses. So in this case, let's say this would be the footprint. The CDN would say, I support HTTP 1.1 downstream delivery in these ranges. Another example would be here, and if you're familiar with CDNs, you can have different types of redirection. Again, here the CDN would, the downstream CDN would signal, okay, I support DNS redirection and HTTP redirection. And again, there could be a footprint saying, you could have, this could be more complicated. You could say I support DNS redirection for this IP range, and I only support HTTP redirection for a subset. So this enables the upstream CDN then to say, okay, I want to delegate this request. Okay, this is cool, I can do it. So where are we at? So we have a draft that actually has been around for a long time, that has some Strawman text for server response encoding. And yesterday I sat together with Richard and John, and we discussed, so John Peterson and Richard Yang and myself, we discussed how we need to move forward. So we need to move in some text from an expired draft from Kevin, which is actually obsolete now because that has a lot of his text has moved to RFC 8008, but some of it we need to move here. And essentially we need to say what is exactly the same as in RFC 7285, so the legacy Alto, and what is new. And we had some discussion, and I think we're going to update the document pretty soon. I have here adoption. I have no strong feelings, but actually when Vijay and I discussed the working group, we said this is actually something that needs to be done because, and I think this is the only candidate out there. So maybe you can.
All right. So this is, as Jan has been saying, some holdover work that needs to complete in order to, do the work that was adopted in that was RFC 8008 in CDNI. So I will ask for a hum for this, but before I do, I see Lyle coming up to the mic. So Lyle.
Just a quick note. One, it's not a hard spec to implement.
It's what?
It's not a difficult spec at all to implement.
No.
And just to be clear, by that I mean the server that implements it for Sprint has been operational for 325 days and about 19 hours.
Okay.
So just so we're clear. All right.
Yeah, but maybe actually then you can provide also some input to Richard and John and myself. Maybe we should get back to you on where exactly what we need to specify, what's different than traditional alto, right? So we had a discussion yesterday with Richard also about server-side notifications, because there we want to make sure that server-side notifications also work with you know, this new object form or the new alto service we're talking about.
I would love to pretend that I'd be of value to that discussion, but it was so long ago and it was so simple, it was almost in the we didn't care.
Right. So maybe I should mention that too before I take down. What we have in mind is also this actually is a simple document just says, for instance, for example, we need to really look it through. Error encoding is the same as in traditional alto. Security is the same, but here is what's different because we have different JSON objects, so some things might be different. That's what we want to do. And again, Richard, Jan, John Peterson, and I sat together yesterday. We have a plan, but yeah, of course, like, we will involve you. Good.
All right, given that it does fit within the methodology and the changes and in Wendy's draft that you will harmonize and make sure that it's reflected accurately here. And given that Lyle gave a good view on implementation status, I will ask for a hum. The first hum will be for those in favor who want to adopt this as a deliverable item. And the second hum would be for those who want to oppose this, or for those who want to oppose it and have a different draft. So for the first hum, everybody that is in favor of adopting draft CDOR CDNI request routing ALTO-08 as a working group item, please hum. All those who are not in favor of adopting it, please hum. Okay, so at least I did not hear any hums against it, and the hums for it are a function of the people present in the room with low energy. So I think we can claim the you know, that we have consensus and move the document ahead. Yes, of course. It'll be ratified on the mailing list, and we'll move this document ahead. All right.
We are on time. This is strange. What happened?
Alexey Malnikov. I'm AG responsible for CDNI. So
yeah,
if you do drop this document, let me know.
All right. So we are actually 3 minutes ahead of time. So we'll add those 3 minutes back to your normal lives.
Well,
and
I think at least and I think you two, we are planning to be in Prague, and we should definitely have a session there, and hopefully by then we can make good progress on the things, the drafts we adopted today, and also on the other ones. So I want to re-emphasize, we think we're on a good path, but let's, you know, finish the charter items and the milestones. Yeah.
Can I just say very quick? I think Sabine had a very good suggestion yesterday, and she wanted, if possible, for example, those also will have some kind of regular offline meetings and sync up. I think that's probably.
I mean, we can have a virtual interim between this ITF and the next one.
Oh, that's a good idea, because I believe personally, I mean, there's a chicken egg. If you don't have meetings, people don't work hard. Yeah. People don't work hard, you don't have meetings. So therefore,
I mean, you know, what has worked in other working groups has been that the people who are interested in moving the work ahead are always welcome to arrange for meetings themselves. You know, you don't have to keep it as a function of the chairs. If for whatever reason you feel that the chairs are needed, or you need some support like bridges, etc., and you cannot get those on your own, then by all means, you know, let us know. But please feel free to, you know, pair up and move the work ahead as needed. All right, folks, for those of you that are traveling back home, have a safe flight, and thank you. See you in Prague.
Yeah. Say again?
Not scheduled Friday.
Yeah, but we cannot schedule. They schedule for us, right?
Yeah, but I can make sure you will not have Friday backups.
Yeah, maybe.
And we're probably also easier if you don't have like a 2.5 hour slot, but only like 2 hours. Because there are more 2 hours slots.
Ah, that's a good idea. Okay.
Yeah, I mean, it's okay. I'm not traveling, so it's okay with me.
No, it's not because of Friday.
The energy,
Just
I mean,
because there are
energy.
less people.
Okay.
Yeah, so like having a meeting with time not on a Friday helps you to get more energy.
Yeah.
Maybe, potentially.
And maybe 2 hours should suffice. I mean, we
Yeah.
always have lots of interesting, sorry
I mean, you
today.
can even, actually, you can even put a note in, because we've been scheduled Friday last time, so
Right.
we would prefer to not be scheduled Friday.